Hey guys, welcome back to week 7 of the Barnabas racer class. So this is the last week. So far, we've taken this guy, we've built him, we've learned how to make him drive, even turn and spin, and then last week we added the ultrasonic sensor and got it to blink the light. So the last bit is learning how to use the ultrasonic sensor and navigation at the same time. So the goal today is to be able to drive our car and then be able to sense an obstacle and then react to it. So whether that's to turn around, probably stop first, right? Stop and then turn around or just turn. So that's what we're going to do. So once we're able to do that, then you can go ahead and do whatever you want with your robot car because you have all the functions. All right, let's go ahead and get started.
Alright guys, here we go. Let's get started. This is code from the last session where we learned how to program the ultrasonic sensor. Now you might notice a few more things here because I added things from previous lessons. So let's go ahead and go over that so that we don't start off all confused. So first thing, let's go ahead and look at this. See, so we added the servo motors because we want to be able to make our car move. So we need to add the include servo library statement. And then the trig and echo, that's from last time. The LED is also from last time. Then we have these three right here. Okay, so we're going with the same convention where we're going to use variables now with these pin numbers to set the pin modes. All right, so we have the button is going to be pin 2. MA stands for motor A, that's going to be pin 10, just like before, and MB, that's motor B, pin 11. Then we have the two servo motor objects that we need to create so we can control them. This stuff right here, same stuff from last time. This was part of our crazy formula to calculate distance using the ultrasonic sensor. Remember the speed of sound here, 343 meters per second. Alright, so now going down in our setup, we set up the trig as an output and echo as an input, and also the LED. This stuff was from the last lesson. Now we also have pin mode button input, because remember to set up the button you have to set it as an input, and button, if you remember this right here, we can look at our variable up here, is set to number 2. Alright. Okay, so this is the same as saying pin mode 2 input. But we were using button instead, because in case we need to change it later and we need to make button number 3 or number 8 or whatever, we can just change it up here. Again, this is something that we talked about last time, just want to give a little refresher. Alright, so the button set as input. And then here is where we set up the two servo motors. Motor A dot attach MA. Now what is MA, you ask? Let's look up again. MA is 10. So we're saying motor A, let's attach pin number 10. And then motor B, let's attach MB, which is number 11, I believe. MB is 11. Okay. Cool. So we set up our button and our two servo motors for our wheels, and then we do stop here. We want to stop because when we first start up the code, we don't want it to do anything. We just want to make sure, like the code, that the car doesn't run away, right? So we put stop. And then this is from last time. We're going to set the serial port so that we can start printing stuff to the screen. We still want to be able to do that because it helps us debug to see what the robot's seeing as we're trying to finalize our code. Okay, so we still have serial.begin. So that's the setup right here. That's the setup method. Sorry, not method, setup function. And if you remember setup, it only runs one time upon boot up. Alright? Alright, now let's keep going down a little bit. Now, I like to do this little fancy block comment here. This is to help me organize my code. I call this, all this stuff, this is all one big block comment. It says car movements. So that means all of these are carve movements. So stop is going to stop them, both wheels, 90-90. I have backwards, forwards, turn right, and turn left. Again, these are things that we talked about and worked on previous lessons, so I won't go into too much detail, but this is where they are. If you need a refresher on why these are the way they are, you can go back and look at, I'm not sure if it was lesson 3 or 4, but you can go back there to do a refresher if you need to. The ultrasonic, I'm going to add a nice little block comment here too. Just to kind of make it look nice and keep myself organized. Okay. By the way, guys, with block comments, the way you do it is that you start with a slash and then put a star, and then you can put whatever you want here. I put stars to kind of just make it look nice, and then I end it with a slash. So that ends your block comment. The key thing, guys, is that this is, they're both forward slashes. So forward slash here and a forward slash there. If I took that away and I put backslash, you see how all this is still grayed out? That's not what we want. That means the comment is still going. It's going all the way down here. See, it's all grayed out. We don't want that. So you want to make sure you go forward slash, whatever you want, and then forward slash again. There. So now my code came back. All right, this was just a little tidbit. All right, so now here's our ultrasonic function. We went over this last time. Remember, we went through the formula of how do we convert time, microseconds to seconds, and how do we convert speed and time into meters. Remember the divided by 2 factor. You can look at the last lesson. I thought that was a good learning point there. About why is it divided by 2? Actually, if you don't remember, try to see if you can remember why that's the case. And then this right here is converting meters to centimeters, and then it returns centimeters. All right. Okay. So this is our code now. Let's make sure that this thing still works. I'm going to go ahead and upload this guy. All right. Okay, I'm uploading. Now I need to open my serial monitor. So I'm going to go here and serial monitor. Okay, so it's like it's working. Go further out. Okay, and if you remember, if you look at the light, this is the light right here. The way my code is written right here is that if it's less than 5 centimeters, the light turns on. If it's further than 5 centimeters, then it turns off. Okay, so now guys, let's add in the motion. Here we go. So let's add in the button. So I'm going to write some code right here that is going to say, okay, I don't want it to actually start printing anything until I press the button. So I'm going to show you something new this time. I'm going to introduce something called a while loop. All right. I'm going to say while, and it's all under lowercase. And while, I'm going to say digital read button equals high curly brace, and then this curly brace is auto generated. Nice. And this is actually, I'm going to put a comment here so you know what's going on. Do nothing. Okay, so what is this madness here? Well, this is saying while digital read button equals high. So let's go back and check. Button, what was button again? Going back up here. Button is actually 2. Okay? So we're saying now button, the reason it says 2 because over here on our Barnabas racer, the button is actually wired to pin 2. So when digital read 2 equals high, do nothing. So if you remember, when you don't press the button, digital read button is going to be high. Okay, so when you don't press the button, it's going to be high. So when I don't press the button, it's going to do nothing. And the reason it says while is because what it's going to do is going to come into the loop, and it says, it's going to say, is digital read button high? If it is, go into here and do nothing. And then after that, it's just going to loop right back and do this again. It's going to say digital read button, is it equal to high? If so, do nothing. And it's going to keep checking and keep checking and keep checking until it tries to do it and says digital read to button, is it equal to high? But then let's say you press the button while it's doing that. If you press the button, if you remember, it's going to go low. So if I press the button, then while it's trying to do this, it's going to say digital read button equals high. Is it true? It's not. Then it's going to jump out of the while and then start doing this stuff. Okay, so effectively what happens is that wait here until you press the button. So basically it's going to loop here, loop forever until you press the button, and then once you press the button, then it's going to jump out and do the rest of the stuff down here. So that's a nice way to add a wait functionality. So let's go ahead and try this. I'm going to upload. All right, so if I do this, you see how it's not printing all the stuff now? You know why? Because it's stuck right here. It's waiting for the button to go low, because it says while the button's high, do nothing. While the button's high, do nothing. While the button's high, do nothing. Now I'm going to press the button, and then it's not going to do anything anymore. Or sorry, it's not going to do nothing anymore. And then it's going to jump down and print something. All right, let's try it. I'm going to press, and we should see something happen here. I'm going to press now. Oh, you saw that? See, all that stuff happened. And then it got stuck again. Why? Well, because it did this thing, it did some of this thing, and then what happens? It jumped all the way back to the beginning to here. And because I'm not pressing the button right now, it's stuck here again. So let me watch. I'm going to push the button. You're going to see some stuff come out, and it'll stop again in a little bit. I'm going to press the button right now. See? It went again and stopped. I'm going to do it again. I'm going to press. See, it went again and stopped. All right. So why did I show you that? Well, this is a quick way to add the functionality where we don't want your robot to do anything until you press the button. And then once you press the button, you want it to start doing something, and then it resets after it finishes. Okay? So let's keep going here. You know what? I'm going to close this for now. Actually, you know what? I'll leave it open. I'll leave it open. Okay. So let's add in forward for forward, and I'm going to move forward for 1 second. Then I'm going to stop, and I'm going to stop for 1 second. Then I'm going to go backward, and then I'm going to go backward, and I'm going to go backward for 1 second, and then I'm going to stop. Okay, so let's review what's going to happen. Once it starts up, it's going to wait for me to press the button. Then I press the button, and then I'll go forward for 1 second, and then it's going to stop for 1 second. Then it's going to go backward for 1 second, and then it's going to stop. And then after that, it's going to do this one time, and then come back up through the loop, and then get stuck here again. Shall we try? Let's try. I'm going to upload. Okay, let us try. I'm gonna press the button. Okay, I think that totally worked. Let's try one more time. Okay. Now, if you notice, it stopped right at the wall. And you might be thinking, oh, maybe it's using the ultrasonic sensor and it's not bumping into it. Well, no, that's just because I got lucky. See, if I push it closer, it's going to hit the wall. Let's see. Okay, see how it hit the wall? Now, the next thing that we want to do, and really this is the biggest part here, is that we want to be able to move forward, but then we want to stop before we hit the wall. So how are we going to do that? Well, we have this ultrasonic thing. All right, so let's play around a little bit. I'm going to get rid of this. I'm going to get rid of that. Okay. And let's see, we want to say we want to move forward. So I'm going to go forward. All right. Now what I want to say is I want to move forward, but I want to move forward and then I want to stop whenever I'm close to the wall. Right? So sometimes when I'm confused and I'm not sure exactly what to code, it's always good to write some comments out and then fill in the code from there, so that at least we get our logic correct. So let's do this. I'm going to say move forward. Okay. So that's fine. That's like we just put this command there. Now here's the tricky part. Keep moving forward until I almost hit the wall. Huh, okay, how are we going to do that? Keep moving forward until I almost hit the wall. Well, that's true. That's what I want to do. I'm going to change around the way I say it by doing this. What if I said keep moving forward while I am far away from the wall? Does this mean the same thing as this? I think it does. Yeah, it does. This one's saying keep moving forward until I almost hit the wall. This one's saying keep moving forward while I am far away from the wall. All right, so this one's saying while I'm far away from a wall, keep moving. And then that implies, but once I'm close to the wall, don't move forward. Stop. All right, so I'm going to get rid of this comment because I like this. Keep moving forward while I'm far away from the wall. Why do I like it? Because look, guys, keyword while. I just taught you this while thing over here, right? Maybe that's why I'm doing this. All right, while here. So maybe I'm going to use this while. It's called a while loop down here too to make this work. So let's see. Keep moving forward while I am far away from the wall. I'm going to become even more specific. I'm going to say keep moving forward while I am more than 5 centimeters away from the wall. So now I'm even more specific, because remember, ultrasonic, this guy, it returns the distance in centimeters. So I can't just say far away. I need to tell it exactly 5, 10, 20. I got to give it a number. So I think 5 centimeters is good. So I want to keep moving, and then once I'm not 5 centimeters away from the wall, I want to stop. Okay, I'm going to get rid of this. Okay, so keep moving forward while I am more than 5 centimeters away from the wall. So how am I going to do this? Let's put some code. While ultrasonic is greater than 5. And then I'm going to do a curly brace, and then press enter, and then the other curly brace will just automatically appear for me. Yep, down there. You see that? Came nice. All right, so while ultrasonic is greater than 5, because look, it says more than 5 centimeters away, what do I want to do? I want to go forward. So this is just going to keep going. It's going to keep going, and then once it pops out of here, when it pops out of here, that means that ultrasonic is not greater than 5. That means that you're almost hitting the wall. So we're going to stop. Okay? I think that's it. You know what? We don't need this anymore. This was for our LED, so I'm going to get rid of this. Okay. Let's try this out. Oh, I need to plug in my robot. Okay, moment of truth. I'm gonna... Okay, all right. So hopefully, when I press the button, it's gonna jump out of this wait thing. It's gonna move forward, and then it's gonna jump into what we call the while loop. It's gonna say while the ultrasonic is more than 5, is greater than 5. That means that the distance is greater than 5 from the wall. It's gonna go forward. It's going to keep looping in here until the ultrasonic is saying, I'm not greater than 5 centimeters of wall. That means I'm almost hitting the wall, and then it's going to stop. After it stops, because we're at the end, it's going to go up here to the beginning of the loop and then wait for the button again. Then it's going to chill here until I press the button again. So let's see if it works. Moment of truth. It totally worked. Amazing. Okay, now I can see I could keep doing it. This is awesome. I'm going to do it this way too. It should work. That worked. And see, it doesn't matter how far away or how close I start it, because it's not based on time. It's based on what the eyes see. One more time, just for fun. Awesome. Okay, now let's see how, maybe I could play with this. Maybe I want to live a little more dangerously. I want to say, you know what? I want to go as close as 3 centimeters away. I wonder if that will work. Okay. Okay, 3 centimeters. Let's try. Okay, see, you can see it still hit the wall. Let me try again. Okay, 3 is not, it's too dangerous. So what's happening is that it's sensing, it's looking for that 3 centimeters, and then, but before it, basically I think what's happening is that it's thinking, okay, is ultrasonic less than 3? Is it less than 3? And then by the time it sees that it's less than 3, it actually keeps moving a little bit, right? It might loop like one more time and then try to stop. But in between the time of getting out of this loop and stopping, that little time interval between there, it actually hits the wall. So you got to give it a little bit more margin. You got to say, you know what? 3 is too dangerous. Let's try 4. Let me try 4. Okay. All right, let's try 4. Okay, 4 centimeters is okay. It's a little more dangerous than 5, but it still stopped. Okay, super dangerous, but still stopped. Okay, still worked. Okay, so 4 still works. Now, here's a little critical thinking exercise for you guys. So remember I put 3 here, it didn't work, it still hit the wall. Because, and I may have not have explained that super well, I'm going to try one more time. Because there's actually a time lag, okay, between the time that it says, oh no, I'm closer than 3 centimeters, it needs to jump out and then stop. Now, during that time, between the time it's jumping out of the while loop and before it stopped, there's a little lag. The car is actually still moving. So what could you do to fix that? How could you keep the 3 there, but still make sure it doesn't hit the wall? Well, I have an idea. What if you slowed the entire car down? If you told it, well, I want you to move slower so that it gives you more time to stop. That could work. So that's something you could play with, okay? And if you remember how to change the speed of the motors, it has to do with the angles that you, if you remember put 180 or 0, that's full speed forward or backward. But if you put like 135 or 140, that changes the speed. So it's not at either super fast or stopped. Okay, so you can play with that again. That was maybe lesson 3 or 4. Okay, all right, so that's a little critical thinking exercise. So there's one more thing I want to play with here. I want to make it so that when I go, I'm going to stop here, and then I want to back up and turn. So not just stop, I want to back up and turn. So let's play with that. So all I have to do is right here, right? Stop. And then I'm going to actually delay 1000 because I just want to stop and just relax a little bit. Then I want to go backward. And let's say I want to go backward for 500, which is half a second. And then I want to turn right. I think, yeah, I have turn right. Yeah, over here. Okay, so I'm going to stop, go backwards, and turn right. Let's try it. Okay. Let us try. Okay, so let's see. The back end of it worked pretty well, but it hit the wall. So, oh, because I put 3 here again. Remember 3 is too dangerous. Okay, let's do 4. Let's try again. Okay. It worked. It worked. Try again. There we go. Okay, so we got the car to move forward, stop at a wall, back up, and turn. So I'm going to stop there for now. So actually, these are the basic functions. You got to learn how to use the ultrasonic sensor, the button, the motors, so that you can turn and back up. And then you got to learn how to put them all together to make your car navigate. So from there, You just take what you learn and then take it to the next step. You guys can have fun with that. So
Congratulations, you have finished the Barnabas Racer. So now that you know how to navigate the car, you gotta be proud of yourself. That's number one. We were able to build it. We had to learn about electronics and figure out how to wire everything, and then do all the coding. Now, if you remember, the coding maybe wasn't too challenging at first, but then we started to add the conditional stuff, and that came in when we needed to learn how to control our robot so it's able to sense and react to the world around it. And so that's when we brought in the ultrasonic sensor, and also the button. The button was part of that. So there you go. You now know how to get the general functionality of the Barnabas Racer, how to get it going, things that you can do as if you want to do further exploration. One thing would be to create an obstacle course or a simple maze and see if you can program your robot to autonomously um, get out of it. So how would you do that? Well, you have a sensor. The sensor can detect walls, and then you know how to make your robot turn. So you can make your robot turn a little bit, kind of back up when it hits a wall, and kind of play with that a little bit. One of the easiest mazes that I have my students solve is just take a box. Imagine a box that has just three sides, though. Okay, so it'd be like, you know, like this, a wall here, and then a wall here, but then an opening up front. So what you do is just put your robot facing this way into facing the back wall, and then make it go forward and see if it can just kind of stop and turn all on its own and find its way out. So that's like a simpler maze. And then if you're able to do that, you can do actually have corridors and hallways and obstacles in the way, stuff like that. But the point of the class was really for you guys to get a feel of what it takes to build an autonomous car. I hope that you have a new appreciation for the Google car or for Tesla and that self-driving thing, the self-driving cars out there. So hope you guys had fun. If you enjoyed the class, reach out. We want to continue to do classes like this, so appreciate you spending time with me and going through all the 7 sessions. Take care and keep on building.